Exponential and logarithmic equations. Question number 1. Find the exact solution of the exponential function. Use a calculator to find the approximation to the solution, rounded to 6 decimal places. Part A. So let's see what we have in part A. They want you to solve this exponential equation. However, there's two approaches that you can do here. So the first approach that I highly recommend is, well, notice that they have the same base, e and e. So if something has the same base, for example, let's suppose I have 2 to the 5th equal to 2 to the x. Look, 2 to the 5th equals to 2 to the x. The only way that these will be equal, identical, is if the exponents are identical. So that's the technique I'm going to approach here. So if I have e and e here, they're the same base. Therefore, these here, like the powers, exponents here, should be identical. So I will say that 3x minus 2 is equals to x squared. So from here, I can a procedure to solve this quadratic equation. 0 equals to x squared minus 3x plus 2. Factoring this guy, we will obtain x minus 2 and x plus 2. So I'm going to erase this part here. So we should get x minus 2 and x minus 2 and x minus 1. That's what we should get there, equal to 0. So if this product is equals to 0, then that implies that x minus 2 is equals to 0, or x minus 1 equals to 0. Therefore, x is equals to 2. That's my first solution. Or x is equals to 1. How about the domain of this function? Remember, the domain of exponential function are all real numbers. So here the domain will be all r. So this is a good solution and this is a good solution. Now, what will be the other approach? The other approach would have been this. So you're going to take the natural log of each side. So we're going to have ln of e to the 3x minus 2 equals to ln of e to the x squared. So using the properties of logarithmic, I'm going to put this one on front and I'm going to put this guy here on front. So I would get 3x minus 2, all of these, times ln of e equal to x squared times ln of e. And remember, the natural log of e is equal to 1. Therefore, you should get 3x minus 2 equal to x squared. And from here, it was pretty much the same approach. Sometimes we're going to be using this a lot. Pretty much most of the time, we're going to be using this. However, if you can see that they have actually the same base, then you can just approach, you can use this. If they have the same base, then the powers, the exponents should be identical. All right. So this would have been done the same way. Now let's go to the part B. Part B, also your range, your domain here for x is all real numbers. So just put here r, everything is gonna work. And actually this guy here, see, we're following the same approach. They have the same base. They have 3 and 3. Therefore, you can just say, okay, 4x is equals to 100. And then we're gonna have to divide by 4 each side, right? By 4 here, by 4. And x is equals to 25. You could have also say apply the natural log in each side and you could have get the right answer. So it will be ln of, this will be the other possibility, right? Ln of this guy here equals to ln of 3 to the 100, and by law of exponent, this way should go to the front and you will actually get the same answer. And then eventually this, if you divide by ln of 3, these guys are gonna be gone. And you have 4x equals to 100 and will get you the same answer. So sometimes notice that if you have the same base here, identical, just right away like this, then the power should be identical, the same. Let's look at this case here on problem C. Well, first of all, I think I need to isolate for my exponential here for this 5 to the x to the 5 to the x over 10. So I'm going to minus 1 each side. So if I minus 1 each side, I will have 5 to the x over 10 equals to 6. See, here we cannot apply the same procedure that we were using previously in part A and B, because they do not have the same base. This is base 5 and this is base 6. So what I'm going to do here, I'm gonna have to isolate each of them by, I need to isolate x, so I need to find the ln each time. So I'm gonna write ln of this guy here and ln of this guy here. The reason why we do that, so is that this power here, this exponent here, is gonna go to the front, so it's gonna be x over 10 times ln of 5 equals to ln of 6. So I'm isolating for x, so it seems like if we multiply times 10 each side, that will do the job. So we'll have x times ln of 5 equals to 10 ln of 6. Now if you divide by ln of 5 each side, then you will get your exact answer. So you got x equals to 10 ln of 6 over ln of 5. So I'm going to write here x equals to 10 times ln of 6 over ln of 5. And we're forgetting something very important here. Say round to 6 decimal places. That's what we probably wouldn't have forgot to do sometimes here, but remember that we must use a calculator for that one. So x equals to, now this is my exact answer, so I'm going to write here this is the exact answer. So but the approximate answer should be, let me pull out my calculator. So if I put my calculator, I'm just going to write 10 times ln of 6 divided by ln of 5. My calculator gives me a really long list, which is about, this is what I have in my calculator, 11.132822753. But they want up to 6 decimal places. So if they want up to 6 decimal places, what I need to do is 1 2 3 4 5 6 up to here. So I'm gonna round it. So if I'm rounding, this will be x is approximated 11.132828. That should be your approximate answer. So this is the exact answer here, and this is going to be your approximated answer. So let's do the next problem. See, once again, these guys do not have the same denominator. I mean, the same base. Like, see, in part D, you have a 10 and a 6. They do not have the same base as previously. You had the E and the E and the 3 and the 3. So what I'm going to do right now is I'm going to apply the natural log in each side. I'm going to put ln here and ln in this case here as well. The reason why we do that is so this power is going to go in front. So you have x plus 3, all of these times natural log of 10 equal to 2x times natural log of 6. Now, if you start using your calculator right now to put the ln of 10, you're going to have a bunch of decimals, and you don't want that. You just keep the ln of 10 there. Treat it like a variable or like a constant. Just treat it, just leave it there. Do not touch it. And let's start isolating for x. This problem seems to be a little bit complicated. So what we're probably going to do here is probably isolate the one with x's. So I'm going to distribute the ln of 10 here. So we'll have ln of 10 times x plus 3 times ln of 10 equal to, I'm going to put here 2 ln of 6 x. So anything that has an x, I'm going to move it to either the left or the right side. It doesn't matter. So here I'm just probably going to do ln of 10 x, and I'm going to move this guy here to the other side. So minus 2 ln of 6x equal to, and I'm going to move this guy here now to the other side as negative, right? Negative 3 ln of 10. So now the reason why we did that is, so look, see this part here? They have an x in common now. Remember that the x is multiplying them, all right? The s is not, it's not ln of 6x or ln of 10x. It's just the x is outside multiplying. So I'm going to factor that guy here. And after I factor, I'm going to have ln of 10 minus twice ln of 6 equal to negative 3 ln of 10. All right. So let me move this up to here. So if I'm going to isolate for x, I just got to divide by this whole amount here. I divide each side by this amount, and then I'm going to get x is exactly equal to negative 3 ln of 10 over parentheses, or you don't actually need the parentheses, ln of 10 minus twice ln of 6. So that should be your answer for that particular problem. That's the exact answer, so be careful. We are also asked to find a rounded solution. So this is going to be my exact answer. So I'm gonna box it here, but with the help of my calculator, I'm gonna have to find the approximation of this guy here. So it's gonna take me a while to plug this in. So I'm gonna just crunch everything on my calculator. So I have a negative 3 ln of 10 all over, so be careful how you input in that, ln of 10 minus twice ln of 6, and that should be approximated 5, so that gives me a 5.39274941. Okay, that's as many digits as my calculator is giving me. So now I'm going to approximate this one. I'm going to have x is approximated to, they say 6 decimal places, 1 2 3 4 5 6 up to here, and this 4 is less, so you're just going to stay there. 5.392749. So this should be my approximated answer. And gladly here, whenever you're doing exponential equations, most of the time, remember that the exponential equation, the domain is actually all the real numbers. Like in part C was all the real numbers, and in part D as well was all the real numbers. Now you have to be careful on that part, because when we go to logarithmics, we're gonna have some of them that our answer is not, it makes sense algebraically, but the answer does not belong to the domain. So that will be for the next following problems. Let's move on. Solve the equation. So once again here, I have another equation, but this equation looks different than the one we have been working on. Actually, you have three terms there, and one of them is not a base. Now, if you look at the problem here, and if you're trying to get, for example, the ln, if you apply ln right away to each of them, it's not gonna work. This has 3 terms, and you know, like even if you isolate this guy to the other side, it's gonna be kind of complicated to do this way. So these kind of problems are kind of made up problems, in which if you have 3 terms, and look at this guy here, this is e to the x, and this guy is e to the 2x. It's like having e to the x to the square, and this has the form of this, like we done it before. Like remember, we had these problems here, a minus 12. It's kind of like this problem here, and that's actually the trick in this problem. This is a quadratic equation that involves exponentials, so we can do this by substitution. You can say, okay, let a be actually equal to e to the x, so we will actually get this function here. We will get a to the square minus a minus 12 is equals to 0. We just do this artificial thing so we can solve this quadratic equation. Now by factoring here, because this is a quadratic equation, we'll get, well, I need to do my structure here. A times a give me a square, and to give me negative 12, I should have a negative 4 and a positive 3. Now once I have that, well, if this product is equal to 0, then a minus 4 is equals to 0, and as well that a plus 3 should be equal to 0. Now solving for a here, you will get a equals to 4, and here you will get a equals to negative 3. So this is my possible solution, and this could have been my answer. However, we're not looking for a. The question is solve for x, solve for the given equation. So we have to go back to substitution. Now we have to say, well, for a equals to 4, we will get 4 equals to e to the x, and we start solving this as we done it previously. So what we need to do here is actually I'm going to have to now apply natural log of each side. So it's like ln of 4 equals to ln of e to the x. The reason is, so you have ln of 4, you have ln of 4 equal to, now this x is going to go from x times ln of e. And remember that ln of e is actually 1. So you have, like, this guy here is 1. 1 times x is just x. So you will have x equals to ln of 4. So now this is your first solution here, the first answer. Now for a equals to negative 3, we're going to have negative 3 equals to e to the x. Now here this is equal to, and then I'm gonna have to apply the natural log each side. Natural log each side, so I'm gonna have ln in this case here as well. Seems to be a conflict here. Look what's going on here. I'm having a ln of negative 3. Wait a minute, ln of negative 3. Remember that this one here, no, it's not in the domain. Like, I'm sorry, this part here, the negative 3 here, this guy here, is not in the domain of ln. Remember that ln is only takes numbers that are positive. So this, therefore, a equals to negative 3 is an extraneous solution, so you're not including that. Therefore, your only solution will be this guy here, ln of 4 equals to x. Now let's go for problem number 3. Solve the logarithmic equations and for x. So what I'm going to do here, first of all, I believe the first step that we have to do in this problem is find the domain of x. Find the domain of x, sure, of the equation, because see, log of 2x, actually this 2x, the inside here, this part inside, this guy here, the inside here should be 2x should be greater to 0, so x should be greater than 0. So far, let's keep that on mind. Now let's start solving. And as I told you before, actually in this particular logarithmic equation, the way how I'm going to show you how to procedure this is I'm going to go back to this property of logarithmic. Remember, you have a log a of x. This is equals to x. Like, these two guys cancel out and you're leaving 2x. So that's what I'm going to be applying in this technique. Look at here, the log here, the base here is 10. So what I'm going to do is I'm going to use this whole thing here, like all of these guys here, as a power, and I'm going to use all of these here as a power as well. So look what's going to happen. I'm going to put a big 10 here in the bottom part. So I'm going to put 10 to this power is equals to 10 to this power. The reason why I'm doing that is so I can get these guys cancel out and I'm left with 2x equals to 10 squared. And 10 squared is actually 100. Therefore, if you divide by 2 each side, you're going to get x equals to 50. So that should be your answer. Now, I'm going to use the same technique here. However, first of all, I need to isolate for the natural log. What I'm going to do is I'm going to divide by 5 each side. So divide by 5 here, divide by 5 here. And what I'm going to get here is natural log of 3 minus x is equal to 4/5. Now I want to get rid of ln, but remember also, similar to this formula is because the base of ln, if I have ln of x, and then the base is e, right? So e to the ln of x is actually x. This guy here cancel out. So I'm going to use the same technique here. I'm going to make these guys here. This guy here is going to be like my power, and this is going to be my power as well, my exponent. So I'm going to raise them to the e to the raised to the power equals to e to the power. So these guys cancel out and you will get 3 minus x is equal to e to the 4/5. Now leaving x by itself, you subtract 3 each side and you get e to the 4/5 minus 3. but you need to leave the x by itself. So either you divide by -1 or multiply times -1 each side. So I'm just gonna procedure this and multiply times -1, and you will get x equals to 3 minus e to the 4/5. That should be your answer. Now you might say, well, is this a solution? Remember that we forgot to find the domain here, and the domain here should be that 3 minus x should be greater to 0. So 3 should be, 3 should be greater than x. Therefore, the domain of this guy is about what? -infinity to 3. And does this make sense? It does make sense, right? X is, this guy here belongs to the domain, so we're fine there. So that's how you're going to be solving logarithmic equations. What we're going to do here is we're going to grab this logarithmic x plus 1 plus log of 2 equals to log of 5. What we're going to be using is our properties of logarithmic. I want to compress this. I want to put it by itself first. So to do that, I must say this guy here, that log of the product of these two guys here. So I'm going to have to be multiplying them. And because multiplication is commutative, I'll just write 2 times x plus 1. And all of this is a logarithmic equals to log of 5x. Now you can also do the analogy, like they're log and log, so the inside must be identical. But just to be safe here, because this is base 10, I'm going to make this 10 to this power and 10 to this power. So this guy goes away, this guy goes away. And you have 2 parentheses x plus 1 equals to 5x. And let's solve this logarithmic equation that was turned out into a linear equation. So 2x plus 2 equals to 5x. Now let's solve for x. 2 equals to 3x, and therefore x is equals to 2/3. Now, however, is this my domain? Let's double check that. Remember that here, for the first part here, the x plus 1, we have to say that x plus 1 should be greater than 0, so x should be greater than -1. At the same time, this part here, the 5x should be greater than 0, so x should be greater than 0. So does this satisfy these two conditions? Yes, it does. So therefore, this one is a correct answer. Let's use the same approach to do part D. Because they have the same base, what we're going to do here is I'm going to put these together. So I'm going to write log, with the base 2, of the product of these guys. So I'm going to put a big bracket. So x plus 2 and x minus 1. All of these equals to 2. Now to get rid of this log, remember the base is 2, so I might put a big 2 here and a big 2 here. So this guy goes away, and I have x plus 2 times x minus 1 equal to, what I'm going to have here is 2 to the 4, 2 to the square is 4. Now seems to be that we're going to have a quadratic equation here. So let's solve this. Let's FOIL x squared plus 2x, x squared plus 2x minus x minus 2, right? Are we doing this correctly? Yes. Sometimes it seems like I went like this in this case, and then I went these two guys. You can go here and then the other way. It doesn't matter, however you prefer. So then I'm gonna have x squared plus 2x minus 2x minus x, which actually was, let me fix this part here. That should be just combining like terms. I'm able to combine there, and I should just have plus x. So let me see, plus x, and then minus 2 equals to 0. So after that, what I'm going, equals to 4, sorry, equals to 4. That should be a 4 there. So equals to 4. I'm thinking about the 0 because we have to isolate for that. We got to make a 0 to one side solving quadratic equation. So I'm going to subtract 4 each side. Okay. And this is what I'm going to get. I'm going to get x squared plus x minus 6 equals to 0. Now this is a quadratic equation, which I can do x, well, factoring, it will be plus 3 and x minus 2. Great. Equals to 0. Because this is a quadratic equation, then x plus 3 equals to 0, or x minus 2 is equals to 0. So what I'm going to do here is I'm going to do x equals to negative 3, or x is equals to 2. But remember, this is a logarithmic, so we have to be very careful on these parts here. X plus 2 should be greater than 0, part of the domain of what values that we need. So x plus 2 must be greater than 0, which means that x must be greater than negative 2. And at the same time, x minus 1 should be greater than 0, so x should be greater than 1. So we have to satisfy these two conditions, that x should be greater than negative 2 and x should be greater than 1. And I believe the only one that satisfies this condition is this guy here. Why? Let's represent this on a graph. So if I were to have my graph here and I have a negative 2 and a 1, so let me do this for the domain for x greater than negative 2 is actually all of these guys here. Now with blue, I'm going to do x greater than 1 should be all of these here. Where they meet, actually your domain happens to be from 1 to infinity. And the only one that satisfies this condition is this guy here. So x is equals to 2. This is not a correct solution. This will be an extraneous solution. It works algebraically, but it's not part of the domain. So we have to be very careful on that. Let's go to the next problem. In the next problem, we have ln of x plus 3 equals to ln of x plus 3. Ln of x plus ln of 3. So this is a very tricky problem. The reason is we were told that there is a property like that you so like ln of a plus b is not equals to ln of a plus ln of b. However, this is an equation, so there must be a value which makes these two guys true. So what are we going to do is let's find that value of x. So what I'm going to do here is I'm going to apply my law of logarithmic, which actually if these guys are adding together, you're adding two ln's. So I'm going to start from here pretty much so I can get space. Ln of this guy here should be x plus 3 equal to ln of 3x, because they're multiplying to each other. Now that they have the same thing here, what I'm going to do is I'm going to have to, well, get rid of this ln by just raising to the e power, right? E to this and e to that. So these guys will go away using the properties. So x plus 3 is equals to 3x. So it wasn't as complicated as it looked like. It's just like we had to use some logarithmic properties here. So if they're adding, they should go back to a multiplication. That's what we've been doing previously. So let's solve for x. So 3 is equals to 2x. And then if you divide by 2 each side, so 3 equals to 2x, I'm going to write again, divided by 2 each side, you get that x is equals to 3/2. Now, is this in my domain? We have to double check that. So from the first part, x plus 3 here, so x plus 3 should be greater than 0, x should be greater than negative 3. And for the second part, I have ln of x should be greater than 0. So you need to satisfy both conditions, right? This and this condition. So in other words, x must be greater than 0, and which happens here is correct. Therefore, this should be your correct answer. A retirement savings plan pays 4.5 interest compounded continuously. How long will it take for an investment in these plans to double? So how are we going to achieve this problem? Well, first of all, it tells you that it's being compounded continuously. So there is a special formula that we've been using lately. So it's the amount after some time of a certain time in years, most of the time, is equals to P E R T, where P is the principal is the exponential, right? R is the rate, and t is the time in years in this case, because we're talking about compounding. So let's see how long it will take to double. So first of all, is he telling you that to double, so the money that you're putting P, because P is the principal, like this guy here, needs to double after how long? So let's talk about T in years, okay? We're talking about in years here. Now, AT, because it has to double, this is the final amount. The final amount has to double, so it just should be 2P, twice the principal. The principal is just P times E to the R, which in this case was given, is 4.5%. And if you convert that to decimal, that should be 0.045. So have 0.045 T. Now let's solve this part here. So if you divide by P each side, the P is gone. So that's what P was in, like a required information. So 2 equals to e to the 0.045 t, and let's solve for t. We've been doing previously that if I want to drop this guy to the bottom part, I must use the logarithmic property. I'm gonna take the ln in each side, so ln of 2 and ln of all of these guys here. The reason why we do that is so this guy here, this exponent here, can go to the front. So I'm gonna go have ln of 2 equal to 0.045 t times ln of e. And gladly, ln of e is actually 1. Remember that ln of e is 1. I'm going to write it here. ln of e is equals to 1. That's a must-know statement. So if you're multiplying times 1, you pretty much have the same thing. So you have 0.045 t equals to ln of 2. So we're looking for t, so we're gonna divide each side by 0.045 divided by 0.045, and therefore t, okay, so t is equal to, well, the exact answer should be ln of 2 over 0.045. So let me use my calculator and see how many digits that is, or what number is that. Probably we should round it just to 2 decimal places, but let's see what we get there. ln of 2 divided by, so ln of 2 divided by 0.045, and the calculator throws me all of these digits: 15.403277068. Okay, so after how many years will it double? It will double after approximated 15.40 years if it's being compounded continuously. Okay, this should be your answer. So make sure that for this particular section, learning how to solve learning how to solve logarithmic equation and exponential function is all based on your properties, on the law of logarithmic. You must master every single law of logarithmic because you're going to be using it all the time.